Hey everyone, what's up? So today I'm going to try to solve this 994 rotting oranges question from LeetCode, and this is one of the most popular questions from Graph. And let's set a timer for 15 minutes. If I'm not able to solve in 15 minutes, or if I think it's not worth it, then we'll probably will see the answer, how it's getting solved. So let's give it a try. I'll try to walk through uh, my intuition behind solving this algorithm, and yeah, let's see. Let's start it. So you are given an M into N grid where each cell can have one of three values. 0 representing an empty cell, it's an empty cell, and 1 is representing a fresh orange, or 2 represents a rotten orange. Every minute, any fresh orange that is four-directionally adjacent to a rotten orange becomes rotten. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If it is impossible, return -1. So I can see that 0 represents an empty cell and 1 represents a fresh orange, and sec 2 represents a rotten orange. In every minute, any fresh orange that is four-directionally adjacent to a rotten orange becomes rotten. Rotten. Okay, so here this will get rotten. Okay, these two, because they are adjacent to this guy, they'll get rotten. Then this guy and this guy will get rotten, and this guy, and then this guy. Then minute 4. Okay, so I've been given 2, 1, 1, and after written 4. So intuitive thought is that I might need to run a DFS. Yeah, it is a graph algorithm, so DFS. But how would I be doing it? So if I go down, like suppose we are running DFS and now we decided to go top, bottom, right, left. So I go down on this orange. So this becomes rotten, and then we have to keep a track of minutes. So here it will be minute 1. So whatever direction we take from here, it will be 1, 1. And whatever direction we take from either of these two, that will be 2. So this becomes 2, this becomes 2. Okay. And okay, so later on this becomes 2, and this becomes 3 actually. This on 2 this will get, and then 3 this will, and on 4 this guy. So we have to keep a counter which will eventually be updated. Um, so it's not that easy, I know that. So to so you are given an M into N grid where each cell have one of three value 0, 1, 2. Every minute any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. Return the minimum number of minutes that must elapse until no cell has fresh orange. So in this case, we just have, so we need to also ask this to the interviewer, that will there be a one rotten orange or there can be many rotten oranges. So if we have many rotten oranges, then that changes the whole equation of this. I guess we can have multiple rotten oranges. How do you do it, man? Um, so here I'm stuck at this point where if there are multiple rotten oranges, what can I do about that? Mm, so okay, guys, this is a tough one. I'm not able to think. So can we calculate the number of fresh oranges in the fresh and rotten oranges? I'm not sure how we can do it. So I guess we are 7 minutes into this and I'm going nowhere with this. So let's see. Um, I'll stop the counter and then probably see the editorial and see how they are. Okay, they are using BFS. This is yet another 2D traversal. As we know, the common algorithmic strategy to deal with these problems would be breadth first search and depth first search. Yeah, as suggested by its name, the BFS strategy prioritizes the breadth over depth. That is, it goes wider before it goes deeper. On the other hand, BFS strategizes depth over breadth. The choice of strategy depends on the nature of the problem, though sometimes they are both applicable for the same problem. In addition to 2D grids, these two algorithms are often applied to problems associated with tree or graph data structure as well. To problem associated with tree or graph data structures as well. Okay. In this problem, one can see the PFS would be better fit because the process of plotting could be explained perfectly with the BFS procedure, that is the rotten oranges will contaminate their neighbors first before the contamination propagates to other. Yeah, if one is not familiar with algorithm, okay. However, it would be more intuitive to visualize the routing process. Okay, so yeah, then this guy. Okay, 7, 5, 3 are the one. 7 is empty, nothing will happen. Okay, gotcha. Okay, in the above graph, unintended, as we can see, starting from the top rotten orange, the contamination would propagate layer by layer or level by level until it reaches the farthest fresh oranges. The number of minutes that are elapsed would be equivalent to the number of levels in the graph that we the number of minutes that are elapsed would be equivalent to the number of levels in the graph that we traversed during the propagation year. Okay, minute one. So let's see, minute one, minute at minute one, we are propagating to this 4 and 2, then 5 and 3, then 8, then 9. Yeah. Okay, so I haven't traversed the matrix other than going other than the DFS. So if I have this grid, and I have to traverse the PFS. I have to first search all the rotten oranges. Um, I have to queue all the rotten oranges inside a queue inside the queue. I have to first of all run a loop through the. What I'm thinking is after reading that I have to run a loop through this and identify all the rotten oranges and put them in a queue. Then, while the queue is not empty, we will run the loop. And okay, so what we'll do is for every iteration we'll keep on adding we'll change the rotten oranges X, and then we'll add that we'll remove the current element and um, traverse its adjacent nodes, and then if it is a fresh orange, then we can make it rotten and then put it in the queue, push it to the queue. Okay, and then finally and keep on updating the number of minutes. Like, okay, so basically, to show you guys, I hope this works. I'm using a miro.com. Okay, so we have this grid, right? Let me zoom in and let's see. Where is my cursor? Or zoom out a bit. Okay, yeah. So let me rub this off. Okay, so here is the rotten orange. And suppose we have orange here, orange here, orange here, orange here, orange here, and then this is our grid basically. So yeah, what we are going to do is loop through this 1 2 0 1 2, loop through this entire matrix and have a queue where we'll store the orange. Let's dry run this if this works. We'll store 0 comma 1 in our queue. Then once we have the queue ready, so we'll run a while loop while queue is not empty, while not queue or queue dot length is there. So yeah, once we do that, then yeah, once we do that, then what we can do is while not queue, we can shift the first item like so I'm using JavaScript, so we can if we use queue dot shift, it removes the first item, so it will be let's take it in row and column, so it will come inside the row and column of this, and then destructuring it. This is basically destructuring it. So once we have R and C, we have to we have to um, like basically add directions. So like +1 to R, and we have to basically do this. Do like update this value, have directions array ready, where we'll give add 1 0. So and okay, sorry. So yeah, this directions array would be 1 0 minus 1 0, then 0 1, and 0 minus 1. So basically we'll loop through this, um, for loop through this direction, update the R and C with the directions value, and see if it is going out of bound. If R and C are going out of bound, meaning if it is R is less than 0, or R is greater than the grid's length, then or C is less than 0, or C is greater than the grid of 0 length, then we have to continue. We don't have to do anything, and if and also we have to check if grid of R and C is equal to it is if it is not equal to 1, then we have to continue, because if it is 2 or 0, then we don't have to do anything for that matter of fact. So in this case, we'll continue. And I know this is looking messy, but please bear with me. So yeah, once we get rid of this edge case, then we have our fresh orange. Then we can simply take that fresh orange, like sorry, we can make that grid of our C value. I will change this value, and then we'll Q dot push the R comma C into the grid so that we have our so yeah, so this is how we'll do it, and we'll update the value accordingly then. So yeah, I get the idea. Let's try to implement it. So let's check first edge case if the grid dot length equal to 0 or grid equal to null, or basically we'll just see then return -1. So we have to return -1 right at the end. And let's have a minutes variable set to 0 until no cell has fresh oranges. Okay, one more edge case I can determine is this minutes has to return -1. So if there is a case where we have a grid which is entirely filled of rotten oranges, in that case it will be impossible uh, to change anything. So in that case we have to return -1, or suppose there are no rotten oranges at all. So return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. Okay. Um, yeah. So we have to make sure that we are counting fresh oranges equal to 0 now, as 0, and rotten oranges or oranges, if I can spell it correctly. So yeah, we have minutes. So let's put them together. We have minutes, we have fresh oranges and rotten oranges. Let's set it to 0, and let's loop through the let I is equal to 0, I is less than grid dot length. So you can always row length is equal to grid dot length, and also you can do the column length is equal to grid of 0 dot length to make it easier. Yeah, row length. Then for let j is equal to 0, j is less than column length g plus plus. So once we have once we are done with this, then we just have to check if grid of I and j equal to is this a string or a number? Okay, it's a number. So if it is 1, then fresh oranges plus plus, else if grid of I and j equal to 2, then rotten oranges plus plus, else else if it is a else nothing, right? Else if okay, one or two rotten oranges. Okay, and there might be a situation where the entire cell is empty, so we have to also consider that. So my thinking is grid can be empty, can have all cells empty, then grid can have all fresh oranges or rotten oranges. In that case, it would be impossible for us to make any move. So we have to make sure that we are testing that here. So if rotten, okay, so how do we do it? So we have a row length and column length. If um, rotten oranges is equal to 0, which means we don't have any rotten oranges at all to begin with, then it's impossible. If we don't have fresh oranges um, equal to 0, then also it's impossible. Yeah, if we just check these two conditions, yeah, if any of those um, two are missing, then yeah, we can simply return -1. Okay, we can just grid if grid have no fresh oranges or rotten oranges, will return -1. And then once after this, we have to run the PFS, and for that we need to have a queue. So should we BFS, let's define the queue here itself. Queue is equal to, uh, let's have it in one place. Let Q is equal to and yeah, one more thing. I forgot that the main logic revolves around um, storing the value in the queue. So we'll have this queue here, and then as soon as we get a rotten orange, we can queue dot push push I J. Okay, cool. So our queue is ready. Then I will scroll down a bit. Then this while loop, while queue dot length is there. Then we have to run this, and finally we have to return -1. Okay, not -1 minutes. Sorry, minutes. Okay, minutes, and let's go here. Let n is equal to n will check the number of elements that are available in the queue at the moment. So we have to run the loop that that will cover the first level of the oranges that we have to cover, that we need to uh, like deal with. So in this case, our queue length will be 1, the one which is being shown here. Okay, so once we have that, let n is equal to q, then while n is not equal to 0, we have to run this loop, and then we have to also create a let directions is equal to for 1 0, then -1 0 row, and this is for column, positive column to go on the right, and this is to go on the left. So this is basically top, bottom, right, left. So once we have that in place, then yeah, here we'll do q dot shift, then let R and C contain the shift value. Okay, once we shift this, we have to run the for loop, the set for loop, right? Okay, let I is equal to let I is equal to 0. I is less than direction dot length I plus plus. Once we get this guy, then what we can do is, then we can just manipulate this thing. Like, first let's get it out in a variable x and y, uh, direction of I, and then let's simply update plus equals to x, or and c plus equals to y. That's it, right? Yeah, once we get that, and then here we have to check if r is less than 0 or r is greater than a row than equal to row length, or c is less than 0 or c is greater than equal to column length, then or uh, grid of r and c is not equal to 1, then we gotta continue. We don't want to pursue this any further. If this guy is the fresh, okay, let's okay, sorry, my bad. For readability, let's add, we got our fresh orange, then grid r and c equals to 2. We'll change that, and then we'll q dot push. Okay, sorry, q dot push push r and c. So we have pushed this guy, and then we gotta do n minus minus, because we took care of one guy, and once we have done with this, then we have to do minutes plus plus. Okay, I believe that I've minutes is equal to 1. Okay, let's do this. Okay, return the minimum number of minutes that must elapse until no cell has fresh oranges. So here, yeah, we can see fresh oranges minus minus. We can do because we did convert a fresh orange to minus, and if in the end we can check if fresh oranges if is equal to 0 question mark, then we can send minutes, or else you can send -1. Yeah, so let's hopefully this should work. If not, let's see, let's debug it. Okay, 5 minus 1, expected output was 2. Okay, okay, if okay, so most of the thing is if rotten oranges, if fresh oranges equal to 0, and rotten oranges is greater than 0. Grid is a number, right? It's a number array. Then we are checking grid of ij, column length 1. So let's console log it. Console log fresh oranges and rotten oranges. Let's see what it gives us. 6, right? Yeah, 6 and 1. Yeah, Okay, yeah. And this case gets solved, and then here, why are we having one extra? Extra, should I keep this plus plus? Like it doesn't matter. Um, okay, 6154. So according to our algorithm, if we see queue dot length, initially the queue should have just to this guy. Then queue should so let's see. We'll console log queue on all the levels. Okay, on all the levels. So initially we should get 0 0, which we are getting. Then this two 1 0 and 0 1. Then after that we should be getting this guy 1 1 and 0 2. Yeah, we are getting that. 1 2 3 4 5. Okay, let's minus 1. Oh, so what? So we just have oranges. What about this guy? I thought, okay, so three test cases, I guess, if we have, so if oranges are 0 and if rotten oranges are 0, fresh oranges, if fresh oranges, so it did solve 117 cases if fresh oranges is greater than 0, and then rotten oranges is equal to 0, return minutes. So we did cover all the test cases. Yeah, this should be sending. Returning test cases. Let's add this guy. What was this guy? Oh, expected is. What the hell? If I submit this, oh, the output is coming out to be 0. So don't get anything. Q.length is empty. This is not happening at all. So fresh oranges are equal to 0. If it is 0, then minutes. So any of you are returning anything? Console log turning last. Okay, put it in this case, right? Or case. Oh, this guy. Run. Oh, yeah, rotten orange is equal to 0. Okay, 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 yeah. Then it doesn't matter if rotten oranges are 0. If there are any fresh oranges remained, okay, what the hell? 1, 2. Okay, I need to see the editorial. I'm close, but it's taking far too much time off for me. Okay. Okay, minutes elapsed. It's saying -1. So they don't have to do a -1 here. Okay, makes sense. From okay, it's adding q.offer. Let's see solutions. Yeah, oh, you know what? I have done this already sometime. Okay, so just 20 minutes plus 1. रुक जा आया है I can do I if grade RC equal to 2. Okay, let me see my submissions. Where the hell am I going wrong? Rich oranges are greater than 0. Okay, yeah, maybe this. Okay, lot of wrong answers. I guess this will help me. Copying this guy. Yeah, let's call it cell. Okay, something wrong with my code. What about this case that I'm, so there is nothing in here. Checking nothing, nothing. Okay, is this code wrong? Do it. Oh, did I put -1 here? Sorry, sorry. So finally, I was able to do it. So the only place that we were going wrong was we have to also track the fresh origins if it is uh, like as soon as it comes to 0, you have to stop doing looping through this loop, and if it is 0, then it's not 1. So it took a lot of time. I'm learning. So yeah, that's the process you have to go through. So time complexity, if we see the time complexity of this would be m into n would be of this guy. We are traversing this, and for BFS, in case we have to go through all the of n, so m into n would be the time complexity, and space complexity would be the same in case you have to store all the rotten oranges or so. N into n, yeah, that's space. Yeah, rotten oranges. If it is filled with rotten oranges, then yeah, that's what. Okay, guys. Yeah, it took a lot of time, but the good thing is I was able to like see the code, like get to the code from reading this part, like understanding how it should be working. So that really helped me to think about how I can do it in a BFS manner. I'm not sure what this second implementation does, but yeah, like it does save you a lot of space of 1, but it's increasing the time complexity. But I would stick to this guy, this process. Hopefully, yeah, I'll improve next time. I'll probably revise this question today or tomorrow. Yeah, thanks for tuning in. If this helps, it helps. Yeah. And let me know if how I can improve my coding skills. This rotten oranges shouldn't be there. I shouldn't have calculated it. I thought it might be useful. So yeah, thanks.